Hey guys, this is the last set of notes for Unit 2. Today we're talking about metallic bonds and intermolecular forces. Metallic bonds are formed when two metal ions share electrons, but they're not shared evenly. Electrons are moving around freely, and we call that a sea of electrons. So this picture shows an example of that. Those little purple dots would be the electrons. They just kind of float around freely between all of the metal ions. A few examples of metallic bonds would be gold bars, aluminum foil, and copper wire. All of those are just metal ions that are just sharing electrons between all of them. Some properties of metallic bonds: they are good conductors of heat and electricity. They have high melting points and boiling points. They have high density. They're malleable, which means that means that they can be shaped into a sheet or any kind of shape. You can kind of hammer them out. They are also ductile, which means they can be stretched or pulled into a wire. The strength of a metallic bond depends on the numbers of electrons that are free to move about the metal and the size and the charge of the metal. So usually the more electrons, or the bigger or the greater the charge, it's going to have a stronger bond. So just to review, we have covalent, metallic, and ionic bonds. Covalent sharing electrons, metallic has an electron C, and ionic transfers electrons. Covalent is between nonmetals, metallic is between metals, and ionic is between a metal and a nonmetal. For melting and boiling points, covalent has low on both of those. Metallic and ionic have high melting and boiling points. Covalent, as far as the property for being hard, they're not very hard except for silicone or carbon. Metallic and ionic are hard because they have a metal in them. For conductivity, covalent has no conductivity, so cannot conduct electricity or heat. Metallic and ionic, metallic has a high conductivity, and then ionic is only when it's dissolved in liquids for the most part. So intermolecular forces. First, you need to know the difference between intramolecular and intermolecular. So just remember that intra means inside, inter means outside. So intramolecular is what holds the molecule together. These are your covalent or ionic or metallic bonds. Those also help determine chemical properties. Intermolecular is the forces between multiple molecules. So these are going to influence physical properties like boiling point and melting point. An example is just that's the bond that's going to hold two molecules together. So let's say I have H2O. H2O is just a lot of hydrogen and oxygen bonded together. But when you bond an H2O to another H2O, that's an intermolecular force. These forces that you're going to learn about from weakest to strongest are called London dispersion, dipole-dipole, and hydrogen bonding. These three weaker intermolecular forces can also just be known as van der Waals forces. London dispersion forces was named after Fritz London, who discovered them in 1930. This is your weakest force. They're created by the movement of electrons. So electrons are negative. That's going to attract to the nucleus of another atom. That force between those is a London dispersion force. It creates a temporary dipole that loosely sticks atoms together. So it's pretty weak. It's easy to break those back up. It's going to be temporary. The constant motion of electrons allows the atom to form a temporary dipole. This can be present in polar or nonpolar molecules. The more electrons that an element has or that a compound has, the stronger this specific force will be. Next, we have dipole-dipole interactions. This is the attraction between a positive end of one polar molecule with a negative end of another polar molecule. So London dispersion could be polar or nonpolar. This dipole-dipole is only polar. The larger the dipole moment, the larger the attractive force. Dipole-dipole interactions are electrostatic, so that just means that there's a force because of that positive and that negative charge. Here's an example of that. So I have hydrochloric acid and water. Both of these are polar, so I could actually dissolve or dilute hydrochloric acid in water. The bond between the negative chlorine and the positive hydrogen, that creates a dipole-dipole interaction because those are attracted to one another. Lastly, I have hydrogen bonds. This is the strongest of the 3 van der Waals forces that we're talking about. It's not an actual chemical bond, so it's going to be much weaker than our covalent, ionic, or metallic bonds. These are an intermolecular force that's between a hydrogen and a fluorine, oxygen, or nitrogen. So it could be a hydrogen bonded to fluorine, hydrogen bonded to oxygen, or hydrogen bonded to nitrogen. Here's an example. So I have NH3, which is ammonia, bonded to another ammonia molecule. The hydrogen is wanting to bond with the nitrogen. So it's gonna be attracted to those lone pairs on the nitrogen. The bond that's between the nitrogen and those lone pairs and the hydrogen is a hydrogen bond. So one other thing to note, we can also draw molecules like this picture on the screen. The black dash, that's kind of on the right side, indicates that an element is on a different plane, and the dash means it's going away from you. So the solid black triangle indicates that it's coming towards you. So we can't draw a 3D shape on paper, obviously, so using these dashes and the solid lines is a way to help people understand what you're trying to note or what you're trying to draw. So why do I need to know about intermolecular forces? Intermolecular forces play a role in determining which state an electron is found. So a solid has strong intermolecular forces, liquids are kind of in the middle, and then gases have very weak intermolecular forces. So you can also think about how particles or atoms move around in solid, liquids, and gases. In gases, they're moving really fast all over the place. So yes, they would have weak intermolecular forces because those particles aren't really going to bond with each other. Solids the opposite of that. Also, we can determine low and high boiling points and melting points. The weaker forces are going to have low melting and boiling points. The stronger forces will have higher melting and boiling points. So the stronger that force is, it's going to be harder to kind of break up those molecules. For example, I have these 3 substances, and I just want to know which one has the lowest melting point and which one has the highest. So first I see what's covalent and what's ionic. MgO is ionic, so automatically it's going to be the strongest and it's going to have the highest melting point. Neon is a noble gas, it's in group 8, so it's going to have the lowest melting point. So anything in group 8, those noble gases, they're super stable, they're not going to bond easily, so we can just go ahead and say it's going to have the lowest. It's also good to note that noble gases can only have the London dispersion force. That's the only interaction that they're going to have. Lastly, we have ammonia, NH3. It has an electronegativity difference of 0.4, so that's going to be polar covalent, meaning it does have a dipole. That dipole arrow points towards nitrogen because it's more electronegative. Because it's covalent, it has a lower melting point than MgO because it was ionic, but it's still higher than neon. So if I ranked them from lowest to highest, I would have neon, then NH3, then MgO. Okay, so that's it for today. You have a couple of questions on this notes page that you need to complete.